Hi everyone, Mrs. Basega here, and today I'm going to help you learn how to calculate mass and weight given gravitational field. So, our essential equation for this is that the weight of an object, that's the force due to gravity, is equal to how much mass is within a gravitational field. A thing to note before you start trying to use this equation: weight is calculated in newtons. So if you see something that's like 500 or 900 N, you're going to substitute that number in for weight, Fg. Mass is measured in kilograms. In the lab, if you had to use something that was already in grams, I would want you to convert to kilograms first by dividing by 1,000. And finally, this G is not grams, it's gravitational field. And field tells you how much force acts on every kilogram of mass in that field. So when I say Earth's gravitational field is 9.8 newtons per kilogram, that means every 1 kilogram of mass weighs 9.8 newtons. So I'm going to show you in like varying levels of problem solving here. If I had a problem that says, how much does a 40 kilogram student weigh on Earth? I know what I'm trying to find is the gravitational force. I don't know what that is, so I'm going to put a little Fg with a box around it down here. That is my unknown. The thing I know is that the mass is 40 kilograms. And because it is Earth, I will be giving you the number 9.8 newtons per kilogram, the gravitational field of Earth. So let's assume it's Earth, we have G, we've got all our numbers. Here's our points. You get a point for writing the equation. Weight is equal to mass times field. I substitute in 40 for M because kilograms, this kg up here, is telling me this is mass. If you have trouble figuring out what is what, a thing you could do is like, when you see numbers, highlight them and then be like, okay, which symbol does kilograms go with? Oh, it's a mass. Highlight all the things that are numbers and then try to solve it. So I've got my 40 kilograms of mass times 9.8 newtons per kilogram. This gets me a weight of 392 newtons. And remember, newtons are small. They're not as big as pounds. So for people, you should be getting weights in the like hundreds of newtons category. If you were getting weights in like the 60 newtons category, then that's probably not an adult human. So what if I take this same human and I'm very mean and I put them on the sun? Okay, so sorry, they're not gonna have a great day with that. On the sun, we see this 40 kilograms of mass, and notice when a mass moves from place to place, the mass stays the same because the student presumably didn't lose any matter in this. Mass stays the same no matter what gravitational field you're in. Speaking of which, the sun's gravitational field is big. If it's any planet, moon, star, comet, anything that's not the Earth, I'm going to assume you don't know its field and I'll just give it to you. In this problem, since I'm looking for weight again, I'm still doing Fg equals mg. So I get a point for writing my equation. The weight of an object depends on how much mass is in a gravitational field. The 40 kilograms of mass stays the same, but now in this like bonkers enormous field, the weight is really, really big. Weight changes as you go from place to place, but mass does not. Mass stays the same no matter where you go. Weight changes depending on field, because a synonym for weight is force due to gravity. That's why its symbol is Fg, force due to gravity. And in regular English, we call that weight. Let's say if we go backwards, what if they have a weight? So I'm looking at this, I'm like 900 newtons. What's measured in newtons is force. We have the weight, we know Fg, but it's asking how much mass do we have? So I'm gonna solve for mass. I'm gonna put a little box around that. Having the knowns and unknowns is nice because then if you're missing a number, you know. And what number am I missing in this case? G, the gravitational field of Earth. Because if I start with my equation, I'll be like, okay, I have this number. I'm looking for M, the number I'm missing is G. So you can kind of process of elimination, figure out what you're missing and see if you can come up with what that number would logically be. And for Earth, because it specifies Earth, it's 9.8. A note on that might be, I'm going to assume it's Earth unless I said something to the contrary. So in a problem, even if it didn't say on Earth, and it said, how much mass does a wrestler have? I would assume it's on Earth unless I say otherwise. Now once I do my substitution, I'm going to divide by 9.8 to the other side. Dividing by 9.8 on both sides gets me M in the numerator by itself. So 900 divided by 9.8, that gets me a mass of 91.8 kilograms. Now, one of the problems I ask you to do in the problem set is to look up like what are masses in kilograms that make sense for a cell phone, an adult, a car, things like that. So you can kind of know off the top of your head if this number is in a reasonable range or not. Like maybe a good conversion factor for you to know is that there's 2.2 pounds in every kilogram. Kilograms are much bigger than pounds. So when I do this out, if there's 2.2 pounds in every kilogram, this person is approximately 200 pounds. Is that a reasonable weight for a human? Hell yeah, it is. So I know this number is within a good range. Last and meanest trick. What if I give you something in grams and ask you its weight? Well, I'm going to need you to convert grams to kilograms before you even get started. So let's say I take this statue my coworker gave me. It says, congratulations on adulting. This statue has a mass of about 90 grams, under a kilogram, 90 grams, pretty small. If I were to find its weight, I would need to convert 90 grams to kilograms. Now, I know the conversion factor is 1,000, but if you're stuck between like, do I divide by 1,000 or multiply 1,000? Here's what I want you to picture. Grams are very small. If this is 1,000 grams to make 1 kilogram, well, 90 grams is only like a tiny fraction of that, right? So I'm going to be dividing by 1,000 to get that tiny fraction. To turn grams to kilograms, I'm going to divide it by 1,000. So I'm getting this nice tiny fraction of a kilogram. So let's say I get a word problem that's like, calculate the weight of this ridiculous trophy in newtons. Then I would convert, that's step 1, convert grams to kilograms by dividing by 1,000. Then times 9.8, because we're doing our mass, times field to get weight. Plugging or substituting all of this in, I get 0.09 times 9.8, or just a fraction of a newton. All right, everyone, best of luck.